1250 for ESP, 350 for motor driver, 180, 450. So this is all about our project, and the total amount is 16,490 pkr, and we divide the total cost. Week 1, and here we will discuss about how we managed over this huge project. First week we will planning and scheduling, team formation, initial research. Then in second week, component outsourcing, schematic designs, and third week simulation and testing. Fourth week, finalization, PSB. In fifth week, we assembles component. In sixth week, IR sensor collaboration, motor testing. And then seventh week, integration testing, obstacle avoidance, logic testing, troubleshooting. And in eighth week, final optimization of our project. Additional remarks: testing environment, line path testing on 2-inch black tape on white floor. Then collaboration tools, multimeters for current voltage testing, serials, monitoring for data debugging, and color charts for sensor tuning. Power backups, 3 cells battery pack with manual cutoff switch for safety measures, fused power inputs, capacitor filters, and proper heat sinking for 7805 regulator. Chapter 2. In chapter 2, we discuss about project conception. Introduction, as by name shows, the autonomous system capable of navigating predefined path while managing dynamic obstacles. The core idea was to integrate multiple sensors and to build manipulations suitable for industrial automation and smart logistics applications. Rapid combine line following obstacles. Then literature review, research paper. We reviewed about research papers: autonomous line follower robot using Arduino, smart obstacle avoiding robot, IoT based robotic car monitoring system, then design and implementation of speed sensing system using optical encoders, or IEEE sensor general 2019, color recognition using TCS 3200, and industrial sorting elsewhere 2021. Commercial products: DF robot line following kit, make block M-board Zomo robot by Pololo. Patents are the given. Then list of features of operational specifications. We have some features, then the descriptions of these features. First of all, line follower, as I discussed in chapter 1, obstacle avoidance, speed measurement, power supply, color detection, display control system, connectivity, data logging. And then we have project development process. Need identification: developing a low cost robot capable of multifunctional autonomous operational. Specific development, concept designs, detailed designs, prototyping and testing, final integration. Then block diagram. This is the main part of any project. First of all, we have Arduino 1, Arduino Uno 1 and Arduino Uno 2. From Arduino Uno 1, we control LFR, and from second Arduino Uno we control the all other aspects like voltage sensor, current sensor, then color detector, SD card, ESP32. These all system level block diagram showing the Arduino Uno SP sensor, display, motor driver, SD card, etc. Deliverable and specification sheets, deliverable specification notes. First of all, the speed, then fully functional line following robot, then obstacle avoidance system, then RPM measurement, LCD interface, IoT data monitoring, SD card logging. Then additional information is costume, PSB, LCD plus Arduino embedded up for space efficiency, chassis fabricated using laser cut a cycle with 2 driving wheels plus 1 caster, microcontroller communication. Then We have chapter 3, product design. Schematic design is done by Abdullah Khan, and main functions are Arduino Uno, TCS 320, IR sensor, RPR sensors, voltage and current sensors, micro SD card module, 16 by 2 LCD parallel, 167,805 voltage regulator. Each component was carefully connected following proper VCC grounds and signal line. The IR sensor were wired to digital analog pins for tracking. ESP32 and Arduinos were connected with UAR pins for a unidirectional communication. The schematic ensured correct placement and wiring before proceeding to PCB. And then we have this PCB in which we show color sensor, power, Arduino Uno, left RPM, right RPM, and LCD. PCB designing is done by me. The schematic was transferred to a PCB layout in Proteus. The layout was manually optimized and compactness minimal. Crossovers and clean routing design rules were followed to ensure trace width via size capability with etching. One layer board simulation. In PCB, I show one layer board simulation, clear power and ground planes. And then logical clustering of sensor and power components, power signal routings. PCB fabrication process is done by Muhammad Furqan. The PCB was fabricated using traditional toner transfer and etching methods on a copper cladded board. Then layout printing. The PCB layout was printed on glossy paper using laser printer in mirror mode. Toner transfer. The printed layout was placed face down and copper side of the board. The household iron. A household iron was used to transfer a toner onto a copper board by presenting and heating uniformly for about 5 to 7 minutes. Then board cutting. Here we cut our board 165 mm into 95 with hacksaw or cutter, ensuring precise fitting for the robot chases. Then the step is etching. This is done by Muhammad Furqan. The board was immersed in a FeCl3 solutions to remove the unwanted copper. After etching, only a toner protected copper traces remained on the board, which is then used as a connection. Then we have drilling. Drilling is done by me. Holes are drilled at the component's pin location using 0.8 mm to 1 mm drill bit suitable for throughout whole component. Then we have soldering. See how beautifully the soldering is done by me. Components were placed and soldered carefully while lead solder wires and temperature controlled soldering irons connections were tested for continuity using a multimeters. Then we have chassis design and assembly. The robot chassis was costumed, made for double-sized copper-clad PCB sheets. The chassis was designed by a two-story frame. Dimension is given. Material, structure, bottom level and top level is also here. Then we have chapter 4 in which we have mechanical design. First, the robot at this position and at this position after connecting a voltage sensor and current sensor, LCD. Then material selection, we select copper clad laminate commonly used in PCB manufacturing. Material properties, first of all, fiberglass reinforced epoxy resin. This is the value of material type: copper thickness, board thickness, tensile strength, flexure strength, thermal resistance, then flame resistance. We have assembly and fasteners. All layers and components of the robot are mounted using M3 stainless steel bolts and nuts paired with base spacer for a structural height between two PCBs level. These bolts are used for fitting over project, as the supervisor advised that the project is as hard as brick. Then we have stress and rigidity analysis, qualitative observation. Although the chassis is not subjected to high mechanical forces. The design account for weight distribution and shock resistance. Then factor of safety, FOS, material strength, assuming maximum weight is 1.2 kg of our project. Then structural design deliverable summary, is all these: two level copper clad base, modular mounting, lightweight and rigid, no moving mechanical parts. All our actuation is electrical. The design ensured low manufacturing cost. Then we have chapter 5, electronic design and sensor selections. Arduino Uno ESP32, L298 motor driver, IR sensors, color sensor, ultrasonic sensors, RPM sensors, voltage sensors, current sensors, LCD display, micro SD card, and voltage regulator. Then we have sensors with specification and feature, as we discussed in the chapter 1. The all features: quantity of infrared line sensors are 3, purpose are line following detection, operating voltage, and all these things. This is our color sensor. Purpose is to sense the color basically. Then we have ultrasonic distance sensor. The main purpose of this to distance obstacle to initiate avoidance routine. Then we have RPM sensor. RPM sensor basically optical encoder, measure the speed and rotation of the wheel. Then we have voltage sensor. Purpose is monitoring battery voltage in real time. And then we have current sensors, power requirements and power supply designs, primary power sources, power distributions. Then voltage regulations. Motor selection specifications are operating voltage, recommended voltage, gear ratios, no load speed, stall torque, small torque. These all torques are of these wheels which we used in our projects. Shaft type, mounting holes, weight. These are our wheels and these are our motors. Feedback mechanism, RPM feedback is used to compute speed, and sensor feedback of the line inform the robot where sensor feedback is basically inform the robot whether it is on or off the line, which he has to follow. Ultrasonic sensors, then color sensor, LCD output. Then we have chapter 6, software firmware design. Software firmware design, input output pinouts, in which in this part we discuss about input output pin, primary control, then module. Then we have Arduino Uno software design. This is our software design. Then we have obstacle detection state. This is the obstacle. Basically, you can say this is the logic for our line following, obstacle following. These all. And then we have project and actual pictures. Project of our actual pictures are these. This is our very pretty project. Excellence, the accuracy is very good. And this is the final picture of our report. Individual execution of the roles. I discuss about my role as a team schematic designer and simulation lead. My primary responsibility was to ensure the circuit diagram reflected our system accurately and efficiently. I studied understanding the requirement of our multifunctional robot. Then one of the most time intensive phases was running simulation in Proteus. I simulated interactions between IR sensors, RPM, IPR modules, and hardware debugging, duration, integration, and was constantly in communication with my teammates to ensure simulation results matched physical outcomes. Then I documented the simulation process, took screenshots of the waveforms, and worked with Furkan on PCB validation. My role also included providing timely updates and guidance to the team to simulation constraint and ensuring theoretical values matched practical expectations. Beyond simulation, I also participated in integration testing, helping troubleshoot systems and calibration sensors. I ensured LCD display alignment, verified sensors readings, and supported Furkan and Abdullah during final testing. This is the outsourcing of Abdullah Khan, and he knows better about his work. And this is about Muhammad Furkan. Success or failure commentary. As my supervisor, As our supervisor commented on our project that we do very excellent work, and failures are some small failures which are faced during the um, simulations and schematic designs and solved by all members. Then team members commentary expanded. This is the expanded part. I talk about my part, who was initially responsible for schematic design and simulation, played very good role, Abdullah Khan. The excellent project is the result of teamwork. In summary, I am the technical validator, Abdullah is strategic coordinator, and Furqan the implementation powerhouse. Together, we complemented each other's strength, covered weakness, and delivered the project for not only met its functional goals but exceeds our own expectation in executing quality and interdisciplinary learning. Bill of material is this 1600 at the last, and Maham Tanveer I word count contribution 2100, Muhammad Furqan 2300, and Abdullah Khan 1980 rupees. This is all about our project, feedback of the project. Our supervisors give us the feedback, references, and in summary, this project has been comprehensive learning journey and integrated hardware skills. We sincerely thank our instructor and lab supervisors for their support, feedback, timely feedback, and encouragement throughout the semester. Thank you so much.